All right, in this video, we are going to talk about problem 5.82 on the carbon tax. It says, and we're going to do parts A, B, and C here. So it says, a poll commissioned by Friends of the Earth and conducted by the Mellman Group found that 72% of American voters are in favor of a carbon tax. Suppose that 6 voters in the United States are randomly sampled and asked whether they favor a carbon tax. Determine the probability that the number answering in the affirmative is A, exactly 2, B, exactly 4, C, at least 2. Okay, so what we need to do, right, is to determine if this is a binomial experiment, right? So, there we have to find out what a success is, right? It says they are asked, we go around and we ask people, we ask them whether they are in favor, whether they favor a carbon tax. So they either answer yes, they are in favor, or no, they are not in favor, okay? And so in this case, right, a success would be, according to how they kind of word the problem, is that they answer that yes, they are in favor, okay? And that also, right, another giveaway is they give us this percentage here, which is like a probability, right? The 72% of the American voters are in favor of a carbon tax. So if we go with success saying that that a person is in favor, then that's the probability of success. So that just makes sense to kind of go with that, all right? So success is that they favor the carbon tax, right? All right, and then the probability of success, right, P, is going to be 0.72, all right? That number that they give us. All right. And so these trials, right, we perform a certain number of trials. We are asking 6 voters, right? So the number of voters or the number of trials would be 6, right? And so that looks good. The one other requirement, right, was that the probability of success does not change, right, from person to person, and that the trials be independent of one another. And so here, you know, they down in part E, they kind of hint around to one question about this, is that really this is another distribution that we aren't going to talk about. So I'm just not even going to worry about that part. So we'll just go with that it's independent, okay? If it's coming from a pretty large population, which Americans are, there's a large population, then it's pretty close, okay? But it's still not exact. So technically speaking, we would use this other distribution, but we're not going to worry about that. Okay, so we have a binomial random variable here. It's the number of successes out of the 6 people that we ask, okay? And what they want to do is ask, in part A, they want to know what's the probability that exactly 2 say that yes, they are in favor. So we ask 6 people, we get 2 people saying yes, they are in favor of the carbon tax. All right, so we need to calculate the probability that x equals 2. Remember, right, we are going with this formula here, right? This gives us the probability that the random variable x equals some number, okay? And so we are going to use Desmos to calculate that out. Okay, so in Desmos, I like to just do P of x here and then type in the formula down here. That's going to be NCR, capital C. And then N in our case is 6, and leave the x in there. So, and then P, the probability of success, is 0.72. Again, leave x in there. And then we're timesing that by 1 minus 0.72. And then to put this exponent, n minus x, in there, make sure you put it in parentheses. So n is 6, right? And then it'd be 6 minus x. So that gives us our formula. Okay. And then here we want to know the probability that x equals 2. So to find that, we can just do p of 2 now that we have the formula typed in. We see that we get 0.048. Let's go with 3 places like that. Okay. All right. That's part A. Part B. They want to know what is the probability that it is exactly 4, all right? Okay, so we already have our formula punched in here, right? And so all we would need to do is do the probability of 4. So that will plug this 4 in for x up here and give us the answer, and that is going to be 0.316 to 3 decimal places. Okay. All right. Next one is on part C is at least 2. Okay. So C is the probability of at least 2. So that's going to be the same as the probability that x equals 2, or x equals 3, or x equals 4, or x equals 5, or x equals 6. All right. Then we need to determine whether these events, x equals 2, x equals 3, all the way up to x equals 6, are mutually exclusive or not. They are, right? Because it is not possible to have exactly 2 people say yes, and also at the same time have exactly 3 or exactly 4 or exactly 5 or exactly 6 say yes, right? You can't have 3 and also have exactly 2, right? So that means that these events are all mutually exclusive, and we can calculate using the special addition rule. We can calculate it out like this. Using the special addition rule. Okay. So we just would add all these up. All right, we have the formula already in here. So all we need to do, right, is to add these up. So I can just kind of type it out. Probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. So I get 0.992. All right, that's kind of the longish way, right, to do that. An easier way would be to do the complement rule, right? So using the complement rule, the probability that I would get at least 2 is the same as 1 minus the complement of that I get at least 2. In other words, that I do not get at least 2. Well, if I don't get at least 2, right, that means that I get 0 or 1. Okay, so you can see that's a little bit easier than that. Again, those events, the probability that x equals 0 and the probability that x equals exactly 1, are mutually exclusive. I can't have 0 and then at the same time have exactly 1, right? So I can use the special addition rule. One tricky thing about this is that because I will have multiple things and I'm subtracting here, then I will need to put that addition, when I split up into addition, inside parentheses. If not, right, then it's very easy to forget that you need to subtract off both of these values. Okay? All right, and so then I can calculate that out. 1 minus p of 0. I forgot my parentheses here. Plus probability of 1. You can see I get exactly the same answer as I did there before. Okay, so you can also use the complement rule in here. It's less stuff that you have to deal with than the first way. One other thing to notice, right, if I forget, right, to put those parentheses, you can see I get the wrong answer, right? It's obvious in this case that that's a wrong answer, right? Because we are talking about a probability, and a probability can't be bigger than 1, right? This number is bigger than 1. So here it's kind of obvious, right, that that would be a mistake. So if you're doing that, right, you need to make sure that that's in parentheses. Okay. All right, and that is it for this one.